Let's begin section 8.4, nearing the end of the chapter about counting methods as well as probability. And here's another type. The other one was a basic, the probability of an event over, the cardinality of the event over the cardinality of the sample space, all possible outcomes. This one is called binomial. So here we're determining two outcomes, either success or failure in that probability concept. But before we go there, let's review some basic understandings that we should have at this level. We understand that any number to the 0 power is always 1. And if there is any number that does not equal 0, then n to the always 1. So we want to do that on our calculator. So let's get our calculator out and let's do an example. 5 to the 0. So here we go. 5 up caret 0. And I hit enter. And sure, it is 1. So we've proven that one. Okay, the other one is this. Now we had it both in our lecture and in our homework. And it states the combination of any value, any sample space to 0 is always 1. That means if I have a group of 5 elements and I choose none to make a group out of, then I have one way of doing it. Okay, that means that there's no way to do it. So then we know this one. If I want a combination of a set and I choose only one, well, there are the combination set amounts that have it. So we want to do this one. On C of 10, choose 0. That one. So I'm going to do, and remember for the calculator, we enter the number first of our sample size, math, and then we're going to go to PROB. We're going to choose number 3 and enter 0, and we get a 1. So we can prove that one too. Then let's do this one. C of 10, choose 1. All right. Well, we should get 10. So we're going to do the 10 again. Math, PROB, and I'm going to do number 3 and put a 1. And I get 10. So these two concepts are clear in your mind. Now let's talk about language. In this section of doing, excuse me, have several words that, several words that imply the difference between two concepts. One of them is precisely, exactly, and that is wanting the probability of exactly a value. What's important, we get into the calculator. So at most means the value listed is the largest possibility. So this means we have to add all combinations, I should say probabilities, all, because that's what we're working on, probabilities including the value. To 1. So if I had at most, oh, actually it's to 0. Sorry about that. If I had that, well, then I would have, so let's do an example. At most 3. So what at most means that we're going to add, combine, cumulative of the probability of 3 plus the probability of 2 plus the probability of 1 plus the probability of 0. At most. That means you can have none, 1, 2, or 3. No more than. No more than. No more than means the same thing as at most. Given you is the maximum number of elements that are acceptable. In the probability. All right, so we're getting it. Okay, and then at least. At least implies all values above the value given. And this one I will go in detail when we get to the exercises. So, all right. So before we really get into the binomial probability, we have to look at the mathematician that came up with, which readily gives us exactly what we need because we don't have to worry about other contingencies in that study. And so what his name, well, he was a Swiss mathematician named Jacob Bernoulli. And look at the time that he lived, and that means a lot of thinking took place. Thought out the idea of experiments where the trial results were only 2 outcomes, making it great because then we either had success or failure. These types of problems were referred to as Bernoulli trials or Bernoulli processes. The 2 outcomes was the development of the binomial probability. Binomial implies 2 outcomes. And probability is the chances of an event happening. All right. My pen is way too dark. So here is the breakdown. I got this from the textbook, and we'll discuss it a little bit, and then I will discuss it all during the exercise. These are the criteria of what is needed. The same experiment is repeated a fixed number of times. So we call those trials. There are only two possible outcomes: success and failure, or all that's option, the binomial process. The repeated trials are independent. That's important. Everything is likely to occur, so that the probability of success remains the same for each trial. Very important about the binomial experiment. So what is a probability? Now we come back to our counting principles. Of all the ways that elements that are being used for the study can be selected, and it is the combination of all possible groupings times the probability of success times the probability of uh, uh, failure. And these can be interchangeable. Now notice the exponents, okay? Here, this exponent represents quantity of success. And this one is the difference, the trials minus, or I shouldn't say trials, choice minus success. In other words, we're subtracting the number that we want to happen in our probability to what we don't want to happen from that set that we start with. And it brings about uh, the concept of X variable, the X variable, the number of trials and which one we're focusing on or which group we're focusing on. So it'll get easier. Now, for example, and the use of the TI-84 graphing calculator to help with these computations. So we are ready to begin with our examples. Okay. And remember, you can pause anytime you like, and we will discuss anything that you need. Remember, I will answer emails. You just have to let me know. Suppose that a family has 4 children. So N is 4. Children. Also suppose that the probability of a girl based on gender assigned at birth is a half. So our P is 1/2. Lowercase p is 1/2. The probability, we want to find the probability that exactly 2 girls and 2 boys are born. All right. So it's success or failure, and they're both a half. So 1 minus p is also 1/2, because this must total to 1. So we have that. So now we're going to construct our problem. So we have 4 choose 2 girls times the probability of a girl to the second times the probability of a boy to the second. This is our problem. So now we're going to use our calculator. Here we go. 4 math, PROB, number 3, and we're choosing 2. And I put my side arrow, times 0.5 squared times 0.5 squared. Success and then the failure. So I get this number. All right, so let me go over here. It's always in front. Here we go. So this is the numeric. But on the first couple of problems, they want a fraction. So we want to hit math. Here's for your notes to convert to a fraction. We're going to hit, after we get the math there, we're going to hit the math key. We're going to choose number 1 frac. Means fraction. Enter. And I think we enter twice. Here we go. So I'm going to hit math. I notice it's frac on number 1. I hit enter and enter. And there it is, 3/8. So this will make your life easier. And since I made you purchase this calculator, we'll see if we can make it pay for itself. So there we go. Now let's do this next one. Suppose we have a family of 6. And also suppose the probability of having a girl is still 1/2. Find the probability of having no boys. All right. So again, we're talking combinations. And we have n is 6, and we're choosing 0. Actually, I'm choosing 6. Let's do 6 girls because we're talking girls. Girls first. And that's very important how they state the problem. So we're saying 6, choose 6. And we want the half to the 6. And then we want the half for the boys to the 0. All right. Here we go. And we're going to go on our calculator. I'll move it over here. And we will write, let me clear that, 6 math, PROB. We're going to do number 3, and we're choosing 6. And then we're hitting the side arrow to come back up, times decimal 5, and then up caret and 6, and side arrow to come back normal, times 0.5 up caret 0, and enter. And we have this number here. So we want the fraction. So we're going to do math. 1 is frac, enter, enter. So I'm going to hit math, frac, and enter, and there I have it. 1/64. That's the probability of getting no voice. Right, so we're getting there. All right. We have a die is rolled 12 times. So my trials are 12. A die has 6 sides. Find the probability of rolling exactly 1/4. One, four. All right. So in this one, we have to consider the trials and how many combinations we have of those trials each time rolling it and making sure that we're only achieving that one singular time of a 4. And it can be through any one of the trials. It can be at the first time you roll it, the second time, but it's only one time that it should show up in any one position there. So we have that. And now we're going to structure the rest. Well, we know that it is 1/6 to get a 4. And that would make it, and we only want it to the 1. And now we have 5/6 times not to get a 4. And that is 11. 11. All right. So let's do the math. And remember, we already know that's going to be a 12. And but we're doing it as a problem because I know you want it to work. Notice I'm going to have time, so I'm going to put a parenthesis, 1 divided by 6, up caret, and I'm doing it 1. And I'm going to multiply 5 divided by 6, up caret, and this one is 11. Okay, these must match the trials or the n of the combination. And I get this ugly thing. Ugly, ugly. So on this one, we are definitely going to use a decimal. And we're going to always go to 4. And that is our probability. Learning more and more. So here we have a die rolled 7 times. So our trial, experiment, trial, is 7 times rolling a die. And we know we want the probability of no more than 4 sixes. Die too big, didn't I? So we want only 4 6s, no more than. We can have less, but we cannot have more. So this means we're going to make a cascade of information. And I need a lot of room, so I'm going to go on the bottom. So I would have, I'll start with my biggest one, right? So I have 7 choose, and I want 4, no more than 4 of the 6s. There's only 1 6 on a die, and we would do the 4, and then I would do the 5 6s, those that are not the 6. Then I would have the 1 2 3 or 4, and then I would have the 3. These two must add up to that. We start with that on the first one because that's what we're wanting. So this is the probability structure for 4. Now I need to make the probability structure for 3 because it could be 3. 7 choose 3. Again, I'm going to have the 1 6 of a desired outcome. I'm going to reduce it to 3, 3, 3. And then I have failure, 5 out of 6 at 4. Now these two add up to the trials. I'm going to have 7 choose 2 because that's possible. And I would have the 1 6. And now I'm at the 2. The failure is 5 out of 6. And that would make it the 5. Notice that everything adds up to the 7. I'm still not done. Now I'm going to do 7 choose 1. And then I'd have the 1 6 to the 1 times the 5 6 to the, oh, okay, now we're at 6 to make the 7 happen. And then my last one, which is 7 choose none of those 6s. Because you can have none and still comply with less than, no more than 4 6s. 0 plus 7 is 7. All right. So now let's do it on the calculator. And I want you to pay attention so that you can do it easily on your calculator. Here we go. I'm going to put it over here. I'm going to clear everything, and I'm going to show you another key for that magic calculator that we purchased. I'm going to put the 7, the math, the PROB, I'm doing the number 3, and choose 4. And then I'm going to do the side arrow to get it back to normal position. And I'm going to multiply by the 1 divided by 6, close parenthesis, up caret 4, side arrow to bring it down, times the parenthesis 5 divided by 6, close parenthesis, up caret 3. Okay, so I have a 4 and I have a 3 to make the 7. The probability of success is 1 6, 1 out of the 6 sides. And the failure is 5 out of the 6. So I hit enter and I get, and we do 4 decimal places. So this would be 0, 0, 1, 5, 6. All right. So now I'm going to do second enter to get the copy of the first one. And I'm going to back arrow all the way to how many I'm choosing. Because now I'm choosing this one. I'm choosing 3. And then I change the 4 to a 3 and the 3 to a 4. 3 and 4 is 7. There you go. Hit enter. Again, we're doing the 4 decimals. 2, 3, 4, 4. Right, I'm going to second entry. And again, I'm moving. And now I was at 3. Now I'm at 2. And so now 2 and 5 make that 7 trial. And I get the, excuse me, let me see what I did too. Oh, mercy sakes. Let me do that one again. Somehow I got a 3 in there. Sorry about that. It should not be more than 1. You know that. So I'm going to delete that. Sorry. I hit a 3 when I was backspacing. Now I've got it. Point 4, 4, 0. What do I have there? Point, let me see, 7, 2, 2. Oh, that's the other problem. So if it's 2, it's got to be 5. Sorry. There it is. 2, 3, 4, 4. When I just did. Okay. Just did that one. So I'm at that one. 7 and 2. And I have 1 6 to the 2 and 5, 6. Oh, 5, 6, 5. And I have that. 2, 3. Okay, got it. What was a 7, 3? I skipped one. That's what happened. Sorry about that. I needed the 3. I jumped to the 2. And that's why the 3 came up. The 3 and the 4. There you go. Mercy sakes, your instructor. So, and this guy is 0.0781. All right, now I'm up with it. So now I'm at 1. Well, it's practice, isn't it? When you're doing this, have patience until I teach you how to do it even quicker. But I found this very efficient. So it's 1, so that one is 6. So now that one is 3907. And I'm now at the 0. I'm almost done. Well, you can see patience is a virtue. Now I make that one a 7. 0 and 7 is 7. And my last one is 2791. And now all I have to do is add them. So here I go. I'm going to add them. I'm sorry about the confusion on the first part. 0, 156 plus 0.0781 plus 0.2 plus M1324 plus 0.2791 and enter. And it's 9979. Pretty certain that you'll get no more than 4 sixes. All right. So this next one, I want you to write it down on your notes. And this is using the calculator to do math on a binomial. And what we have here is the second bars, and a window for statistical applications will show up. You're going to arrow down to the one that says A, binomial PDF, and that is if we have exactly a number, and CDF if less than or equal to or greater than or equal to occurs. And we're going to have to use cumulative. This is cumulative. And then we enter the values in this order. The trial value, the trial value, followed by the P, the probability of success, and X, the desired outcome. The X is called the variable, how many you want. Okay. Then enter to paste it on the home screen, and enter for the probability. So that's the order of what we'll do. And I'm going to stop right there. I've been talking a lot, and I will take up at that after that point.